How's it going? We're going to talk about oceanic circulation. We've talked about the parameters that affect how water moves. Now we're going to look at how it actually moves in our oceans. Okay, so let's get started. First, we're going to see how those parameters make water move. And we're going to look at it for two types of ocean currents. So let's start. The overall ocean current we call the thermohaline circulation. This actually is easy to remember because thermo comes from temperature and haline comes from salinity, salt. Okay? So the thermohaline circulation is the oceanic circulation. When you look at that circulation, what tends to happen is that warm water travels along the surface and then gets cooler, falls deep into the ocean, sinks into the ocean, and then comes back and then comes up to the surface again. So we're looking at two types of currents. We have the surface currents going in the northern hemisphere going north, and then we have the deep currents, which is the water coming back under the surface. Okay? So when we look at what really influences the thermohaline circulation, it is this. It is the density like we talked about last time. And that is really what's pushing the whole thing to move. It's really the motor behind all that movement. So when we look at the deep currents, they're primarily pushed by salinity and temperature. And we looked at how salt makes water more dense and heavier, and how hotter water is less dense and colder water is more dense. Okay? Let's look at just that and look at this. Okay, so I drew the Atlantic Ocean. Here we have Montreal, North America, Europe. What's going to happen in the ocean? So let's start near the south. Okay, near the south we have evaporation. What does that cause? That causes the salinity to go up, right? It's removing water and leaving the salt, so it's going to get saltier. Also, as it's traveling northward, okay, along the surface, this is going to start getting colder and colder and quite cold over here. So you have salty water, which is saltiness increases density, and you have it getting colder as it goes north, and at a certain point it becomes so dense that it will actually sink deep under the surface. Okay? That cold water, which takes some melting ice, but that cold water will tend to come back, and since this is getting warmer from the warm temperatures in the sunlight, it's going to want to, as it's getting warmer, it's going to eventually want to rise up to the surface, and the whole cycle continues. Okay? This is what's really driving it, salinity and temperature. Here you have evaporation, and you have sun heating the water. As it gets north, it's salty water, but it's getting cooler, and it eventually sinks. That cold water comes back again and warms up and rises to the surface, and that's what's really pushing this all to happen. So you need to remember what affects subsurface currents. On the surface, there are three things that affect the surface currents. They're not really the motor behind everything, but they do affect what direction they go. Okay? First of all, prevailing winds. It turns out there's some pretty strong winds that we call prevailing because they happen quite regularly. They're pretty constant throughout the year. That go up along the coast and towards Europe. We call that the Gulf Stream. It creates a current that goes north. The rotation of the Earth. The rotation of the Earth isn't a huge influence on the direction of motion, but it actually does change it. So if it's rotating this way, if the Earth is rotating, basically it's going to change the path a little bit to the left or to the right for certain ocean currents. And then the tides. The tides are caused by the moon pulling on our water and pulling a bulge of water towards where the moon is. The moon goes around the planet about once a month, but the planet's only turning once a day. So as the moon goes over different areas of the Earth, it's pulling water and causing some surface currents. you have to memorize these. You have to know that surface currents are caused by winds, by rotation of the earth, and by tides. And deep currents are caused by differences in density, and that's because of differences in salinity and differences in temperature. And these are the main motor for the thermohaline circulation. And by the way, the importance of the thermohaline circulation is that it is taking a lot of the heat from the equator up to the north and sharing it there. And then as it cools, it comes back and takes more heat up north. It is sharing what is a hot area near the equator, taking some of that heat and bringing it up north. So it's making the temperatures in the north much warmer and the temperatures in the equator much cooler. If we didn't have this circulation, things would not be as good. And the reason is the north would be much colder and the equator would be much hotter. The temperatures would be much more extreme. Unfortunately, because of global warming, that circulation is slowing down. And we don't really know what's going to happen. So hopefully we can tackle this problem. See you later. Oh, wait, the recap. So as a quick recap, we have thermohaline circulation circulates everything, circulates the ocean water pretty much around the globe. I am only showing you one part. We have deep currents, which are caused by differences in density, which is salinity and temperature. We have surface currents, which are influenced by prevailing winds, rotation of the earth, and tides. And this is also very important. At the equator, the water is heated. A lot of it evaporates, leaving the salt, which makes it saltier. That salty water goes up north. As it goes north, it cools down, it gets more dense, and it sinks and becomes a deep ocean current as it returns. So that's about it for this lesson.